All right, so this is going to be the last video of my basically Unit 4 videos. We're doing... All right, sorry about that. So we have difference of squares up here. We're going to start off, kind of do our first couple examples here. So, and then sum of cubes, difference of cubes. I'm not really going to go too deeply into these. Again, I'll kind of just mostly show you the examples. And kind of work them out how we work them out. So, all right, so first thing I'm going to do, I'm just going to write out the questions we have. So with difference of squares, actually we technically have, we have 4 questions. The first question is always, can we factor out a GCF? That's basically the first question you always ask yourself, you know, when factoring out anything, okay? Now, with what we do secondly is we look... There we go. So sorry about that. We're looking to see if we can factor out, no, actually, so with difference of squares, we look, first thing we look for is, do we have a subtraction sign? All right, so subtraction. All right. So basically, it's all in the name there. Difference of squares. The difference basically means that we want to make that they need to be a difference, not a sum, but just a difference of squares. All right. So that's just subtraction. Now this is for difference of squares. When we get to doing cubes, we can do basically, you know, addition and subtraction. Going to 3 here. Do we have perfect squares? All right. This is perfect squares. I'm supposed to say a square, so I apologize. Come on. I'm supposed to say square, so perfect squares. So make sure you know the perfect squares. If you need to get yourself a list of perfect squares, make sure you do that. And then last but not least, do we have exponents that are even? Okay. Now, these last 3 questions, you have to get an answer of yes on. You have to have a subtraction sign. The numbers that you're dealing with have to be perfect squares, and your exponents have to be even. If they are not, if you answer no to any of these questions, then you cannot factor this by difference of squares, and you need to find another way to factor or just write prime, okay? So if you need to pause, write these questions down, go ahead and do that. I'm going to pause the video and erase, and we'll come back to work out these examples. Okay, so I have erased the questions, and now we go to example 1. So first of all, let's look for a GCF. Well, 144 and 1, there's not really a number that's bigger than 1 that can divide both of those, so let's go ahead and move on. 144 and 1, there's no x's to take out. So first, do I have a subtraction sign? So I see here, yes I do. Okay, I can move on to the next one. Do I have perfect squares? And well, 144 is the same as 12 squared. And 12 times 12, and 1 is, well, we can just write that as 1 squared, which is 1 times 1. So yes, I have squares, and then lastly, my exponent here is 2, which is an even number, so we can go ahead and move on. So once we've answered all those questions as a yes, then we can move on by basically, as we were doing with factoring, by trinomials. We'll set up our 2 parentheses here. And in this first term, for both of the binomials, now we're going to have 2 binomials here. 2 terms in this first one, 2 terms in the second one here, okay? For this first term here, I'm basically just going to take the square root of this 144x squared here. Now let's do that in groups here. What's the square root of 144? Well, it's basically 12. I wrote it over here. So 144, 12. So I write that in both of my terms, Now we still have the x attached to it. What is the square root of x squared? A bit of a kind of a rule to know about this is essentially if you have an even exponent and you take the square root, just take the exponent divided by 2, and this is the new exponent after you take it out of the square root. So we know that the square root of x squared is just going to be x. So I'm just going to write 12x next to that. All right, so I'm done with the 144x squared. Now I move on to the 1. I take the square root of 1, and well, that's just 1. And again, I write that in both of my terms, okay? And then the last but not least thing is I put a plus and a minus sign in both of my binomials, all right? Doesn't matter which one has the plus or the minus, just make sure that when you have both your binomials, at least one of them has a plus sign and one of them has a minus sign, all right? Okay. So, move on to example number 2 here. Example number 2 here, all right? GCF is out of the question. I can't take anything out of this, so I look for my subtraction sign, yes. Again, just to reiterate, if you do not see a subtraction sign, automatically stop what you're doing. You cannot go any further with what we're doing. And then look for your perfect squares. The only number we're working with here is 225, and 225 is the same as 15 squared. So yes, we can write that as a perfect square. And then lastly is our exponent here even, which yes it is. So we move on, all right? Move on down here. So once we've answered all our questions, yes, we set up our 2 parentheses, okay? And then we take the square root of the first term and we write it in as the first term in both of our binomials. The first square root of the first term, square root of 225 is, well, just the square root of 15, okay? And we write that in both of our binomials here. All right, that's not a good looking 15 there. And we have the x4. We take the square root of x4. Well, just remember, take the exponent, divide it by 2. That's your new exponent. So 4 divided by 2 is just going to be 2. That's going to be the exponent. That's going to be your x in both of the binomials. And then last but not least, plus and minus. Plus and minus. That's basically it. That's basically difference of squares right there. Go to example number 3. Can't take out a GCF, and I already know I have my plus sign here. So I already know that I can't go any further with difference of squares. I might be able to see if I can do anything else factoring wise, but as far as difference of squares goes, we're off the table. And we can't take out a GCF. We don't really know how to factor x to the 10th power, so we can just do prime, okay, for that one right there. Because again, if you see a binomial with an addition sign, you're either taking the GCF out, you're either doing a sum of cubes, which we'll get to in a second, but we're not doing difference of squares. Once you do an addition sign, this method that I'm showing you is completely off the table, okay? Alrighty, so let's go to example number 4 here, all right? And for the first time that I have here, we can actually take out a GCF. So I can actually take out, well, 50 and 18. We can divide those both by 2. And x10 and x6, I'm actually going to take out an x to the 6th there. And let's see, let's erase some of this here. And so what I'm going to be left with inside is, well, 50 divided by 2 is 25. x10, take away x6 is just x4. 18 divided by 2 is 9. And then x6, take away x6 is that. So, okay, so now I'm left with a new binomial inside. And now I can't take any more GCFs out of that, so now I go through my other questions. Do I have a subtraction sign? Yes. Are my numbers 25 and 9 perfect squares? Yes, they are. 25 is equal to 5 squared, and 9 is equal to 3 squared, okay? And then my exponent here is even. So we're even, so we can move on with our method here. We still write the 2x to the 6 on the outside. We set up our 2 other parentheses. This first term here, the 25x to the 4th, I'm going to take the square root of that. And let's break it down. The square root of 25 is, well, 5, so I'm going to write that again. Both terms. The x to the 4th, if we take the square root, again, we just divide the exponent by 2. It's going to be x to the 4 divided by 2, which is just 2, which I'm going to do in both parentheses. Nothing for that first term. Now I move on to the second term. And the second term in my both parentheses here. 9, take the square root of that. That's just going to turn into 3. And I have nothing else to take the square root of there. And then last but not least, we just do plus and minus. And that is it. All right? Okay, so let's move on to sum and difference of cubes. So I'm just going to quickly write out, I'm going to pause the video and quickly write out, actually I'm going to get a different slide here and kind of write it out here. So I'll show you in a second. All right, so going back to the sum of cubes and the sum and the difference of cubes. So again, for this one, you can use both addition and subtraction signs. And the biggest thing that I want to point out here is when you do a sum of cubes or difference of cubes, you're gonna be left with a binomial, two terms, and a trinomial. All right, so binomial, I'm just gonna write bin and then T-R-I-N, trinomial, okay? In your binomial, the operation, it's literally gonna be A and B. You start with A, your original is gonna be a cube, A3, and another cube, B3. When you take the cube root of both of those, the operation of that binomial, because again, in a binomial, your operation is either going to be addition or subtraction. The operation of that binomial is going to be the same operation as your original problem. So if you have a plus sign in your original problem's binomial, in your new factored binomial, you're going to have a plus sign as well. Same goes for difference. If you have a subtraction sign in your original problem, your new factored binomial is going to have a subtraction sign. And now when we get over here to the a squared minus ab, or the a squared plus ab, when you have the trinomial, you're going to basically take your a and b value and square them, and then also take your a and b value and multiply them. When you multiply your a and b value, the operation in front of that is going to be the opposite. So if you have a plus in your original binomial or a minus in your original binomial, it's going to be the opposite of that, okay? Okay, let's quickly work out a few examples here, all right? I might be able to get to one, okay? So, again, questions that you want to ask yourself. Again, GCF. We don't really care about the plus or minus because, you know, they can be both sum and difference of cubes. So we're going to skip that one and basically ask, do we have perfect cubes? And again, just like the perfect squares, just make sure you guys, know what your perfect cubes are. And then 3, are our exponents divisible by 3? Okay. All right, so what we got. So those are our questions there. Let's go ahead and work out a few examples. Let's work out one example. I think I got time for maybe one example. Might be able to get to two, depending on how I can squeeze the time in here. All right, so x to the third power plus 27. I can't really take a GCF out of that. So I move on to my next question. Perfect squares or perfect cubes, and they have to be perfect cubes, or else I can't factor this method. 27, which is a perfect cube, we can write that as, well, 27 is just 3 cubed. And then the x cubed. And then my other thing, my exponent, my x3. Well, my exponent's divisible by 3, so we can move on. So we set up our first binomial. All right, again, we're going to set up a binomial and a trinomial. Let's go ahead and set up our a and our b value, okay? Now remember, our a value is essentially taking our first term and cube rooting it. And just kind of like we were doing with the square root there, we're basically going to take our exponent, and this time instead of dividing by 2, we're just going to divide by 3. So x to the 3 divided by 3 is just x to the 1, all right? That's our a value. Our b value, that's going to be 27. Take the cube root of that, all right? 27, cube root of that is 3, okay? Now we can set up our binomial. It's going to be x and a 3. And when we set up our binomial, remember, it's the same operation as our original problem. So it's going to be x plus 3. We set up, now we go to our trinomial. First term is just a squared. It's going to be x squared. Second term is going to be b squared, 3 squared, which is going to be 9. All right, always going to be a plus sign in front of that last term, and then last but not least, we have a times b, which is just 3 times x, which is 3x. And then the opposite operation in front of the 3x, which is minus 3x. All right, that is it.